Hi everyone. Today in this demo, we're going to show TruSeq Standard mRNA kit running in the ePmotion 5075T. In this 5075T, we only have a thermal module on the C2 position, as you can see here, TM2. In the application, originally it was designed for another thermal module on the C1 position. So today we are going to assume that there's a thermal module on the C1 position and doing temperature control, and the applications that are exactly the same, except it doesn't heat up on C1 position. Today, because this application was written for 24 samples, and for today's demo, we're going to run only 8 samples today. In this first application, they are going to run purified and fragment RNA. We're also going to run a first strand synthesis, second strand synthesis. In the different application, which is the second application in the folder, it's going to run the A-tail link and ligation. On the third application, it will run PCR amplified and enrichment DNA fragment. For today's demo, we only focus on the first application, which is purified fragment RNA, first strand and second strand synthesis. Right. So as you can see, this is the table here. Originally, we are using 200 microliter tips with filter. Unfortunately, we don't have filter tips in our lab, so today for the demo, I'm going to use 200 microliter non-filter tips. This is the work table setup here. You can see this is 2 boxes of 50 microliter filter tips, and we have 1/2 box of 300 microliter non-filter tips and 4 box of 300 non-filter tips, and an empty box here. Because we are not going to use that much of tips. On the second, we have the magnet here with holding a semi-skirted plate, and we have thermoblock OC on the TMX. This is thermoblock OC, and it's holding a semi-skirted plate. We have 3 position reservoir rack on the A5 position. We have 4 reservoir top here, and I only put water, but the third one, this is ethanol, 80% ethanol. And we are using 5 1.5 ml tube to hold different reagents, including the beads. Right. So this is the setup. Today we are running under the surface mode, which means we don't need to close out the sash. But in the real run, for the customer side, we always have to close the sash in order to protect samples and protect the person who controls the pollution. So let's start it. So this is today's setup. We're going to detect the volume because we have a reservoir rack, reservoir top on the reservoir rack, and we want to know how many volume of liquid was placed inside. We want to detect tips because we don't have the 4 box of tips on the work table. We're going to check the label placement. So they will ask you how many samples you have. As you can see, the maximum is 24, and today we're going to run 8. They will ask you how many volume of liquid in the DRP and CDB plate, and we place 50 microliter, and they need 12 for today's run. For the second plate is empty plate. We just use minimum volume. We have 500 here. We're going to use the minimum volume for the rest of the reservoir rack reservoir top because we're going to use a level sensor which will detect the water level, liquid level. Okay, let's start it. So first they are checking the tips. So they're checking what kind of a tips inside the tip box and checking whether this is epitope EP motion tips or not. Then they are going to count how many tips in the tip box. So as you may notice, the first box is not completed full. They only have 88 tips inside the box, which they lack the first column of the tips. So once they detect it, they will show up here. Says there's only 88 tips in the first tip box. So they are scanning the second tip box, which is 4, filled with 15 microliter filter tips. Now it is checking the P2 position. That is 300 microliter unfiltered tip box with only half amount of tips inside. Right now it's counting. And because it is only half box of the tips, so it tells you that only have 48 tips inside this tip box. Now it's counting on the B3 position. It have 300 microliter tip, non-filter tip box. It's checking whether there's a plate on the magnet, whether there's a adapter on the C2 position, and checking the C3 position if there is a reservoir rack. And on the first position on the reservoir rack, we have 1.5 mil TC module to holding 1.5 mil tubes. And right now it's checking on the fourth position whether we have a 30 mil top, same as fifth and sixth and seventh position. After that, they will check the liquid level in all the tubes. Now checking the first tube on the second rack. And they say there's a lead there. Let's check if there's a lead. Okay. There's no lead here, so we just repeat scan. We pass it. And right now it's checking whether there's a the liquid level in all the 4 reservoir top. After detecting, you can see in the running log, they will show you how many volume they have on the 4, 5, 6, and 7 reservoir top. And that should be enough for running our A-sample RNA TruSeq messenger RNA. So right now they are checking the last 300 microliter tip box. There's nothing there. So right now he's checking the 3 position reservoir rack on the A5 position. Checking what kind of reservoir top inside the rack. And then they will check how many liquid volume in each top. And on the C position, we have mineral oil. So right now it's checking what kind of tools we require or we need in the emulsion and see if we have matched tools on the work table. The first is they're going to dispense 50 microliter of beads. Into the first column of the RBP CDP plate. Then they're going to use a channel tools to mix these beads with the samples. As you may notice, they skipped the first column of the tips because we are using the first 1 tips out, so they only have 7 tips left in the first column. So once they mix the beads with the samples, they're going to vortex the plate. You can see it start vortexing. We're supposed to vortex for like 2 minutes, but because of this demo, I cut in all the vortex heating time and waiting times for the beads, like drying time, cutting to only 10 seconds. So right now it's adding mineral oil on top of the sample. They have a pre-wetting step. The uptake oil dispensing. So the mineral oil will form a barrier on top of the sample to prevent get drying or evaporated during the processing. So it's waiting for temperature on temp 2 to reach 70 degrees. So right now this one is heating up to 70 degrees. If you don't know the temperature, we can click on the EP motion icon here. It will show you the temperature units. On unit 2 is 55 degrees. We have to wait until it reaches 70 degrees, and then the next step will start working. So we have this waiting step to ensure all the temperature was reaching the desired temperature, and then move the plate on it. Otherwise, the temperature will not be well controlled. So this is kind of protection, prevent the time counting on the samples. They are sitting on the temperature they are, which is not reached to the temperature we desire. So right now it's 60 degrees. So in this application, we do all the first strand synthesis, second strand synthesis, incubation on the EP motion. In another application, we can write user intervention and move your plate to the thermocycler and run it on the thermocycler instead of running on the EP motion. And the good things for that alternative application is you use a thermocycler, which is much easier, and we don't use oil. You don't need to use add minimal oil on top of the samples, and you don't have any problem with washing and bead washing step. But the problem is you have to ask people to move the plate from EP motions to thermocycler and put it back. The good thing for this protocol is you can walk away and just let EP motion do everything. So right now it should be waiting in the. We should wait for 5. I think it's a 5 minutes. Heat up at 70 degrees, but we just change it to 10 seconds. So once it's finished heating up, they will cool down on the C1 position, which we're supposed to have another thermal module cooling the plate. In the original application, it writes for need to wait for a minute, and here we just change it to 10 seconds. So we're going to move the sample from the bottom of the well to the second well. So try to avoid as much as the oil on top of the layer. It's better for washing and processing the rest of the stack. So we can control the EP motion to aspirate from the bottom or aspirate from the just a little bit below the liquid level. So we can choose whatever we want. We can select mixing at a certain height or just mixing with the liquid level. So right now because we have a plate on the magnet, we have to move it to other place and then move the RBP plate to the magnet, try to pull down the beads. And today we don't have beads inside, we only have food coloring there. So you won't see the beads was pulling down. I'm sorry, I do put the beads there. So you will see the beads pulling down. But the problem is I don't give him enough time to do this. So I only give them 10 seconds. So you will see still a lot of beads remain in the solution. So now they're going to do a washing step. the first thing is going to remove the liquid in the well. So you can see this, most of the beads are dragging down, but you still see some color in the well. So they are using 200 microliter tools to aspirate the liquid out. And I'm going to do wash. With 200 microliter of ethanol on the reservoir rack at 6th position. So first thing, I have to move the plate to Vortex TMX module. And then they will add in the 100 microliter beach wash buffer. I think this is beach with suspension buffer, and they have mixing set here. And after mixing, they're going to vortex the beads. And then move plate to the magnet. It's supposed to stay at magnet for 3 minutes. 5 minutes, I'm sorry. And we only give them 10 seconds. So the bead, you can see the bead was pulled down, but it's not completely pulled down by the magnet. And then do empty step. So for the empty vessel command, they have 2 steps. The first step is aspirate solution out. And the second step is going to the very bottom of the vessel and aspirate any remaining liquid from the bottom and discard it. So next step, they're going to add 50 microliter of beads suspension solution and do heat elution at 80 degrees. So remove the plate to TMX. And dispensing 50 microliter of solution. This is elution buffer, and then mixing for 5 times or more than 5 times. I think it's 10 times here. After mixing, we're going to move the plate to 80 degrees, which is on the thermal module and C2 position. So right now, here is about 82 degrees, and we're going to add some oil on top of the solution to prevent evaporating during incubation at 80 degrees. So at 80 degrees, in the protocol, it will incubate for 2 minutes, but we just cut down to 10 seconds, and then we're going to move it to cool down on TMX. For another minute to cool down, and same things, we just cut it short for 10 seconds for the demo. After this, the TMX will increase the temperature to 25 degrees. Then we're going to add 50 microliter of beads binding buffer. So it's waiting for the TMX reaching 25 degrees. Same thing here, the TMX right now is 70 degrees, and it should reach to 25, and then we'll continue the next step.